Hello everyone, my name is Shambhavi and today we are just going to discuss about the dataset. Like what we are going to do is we'll be taking a dataset and we're performing some data analysis, some exploration data analysis, some mathematics in that data, and we'll just come out with an output. So for today I would just tell you that how to use the data, how to use the libraries, and after that we'll be moving towards the different type of scatter plots. Fine, I would be telling you that basically how we make scatter plots, right? So let's get started with the things, and for that just let me do one thing. Let me just do a little bit of zoom in so that you can just have a proper idea, and that is too much, right? Okay, fine. Now I hope just it should be visible to everyone of you. Fine, let's get started with the things. So for now, like what I just told that whenever you want to use any library, right? So this is the thing that I'm just telling you on my previous data analysis videos and even in my NumPy library videos, that whenever you want to use any library, we basically import that library, right? Now what I would do, I would write import, and here I would write NumPy as np. So for the ones who are just new for my channel, I would like to tell you one thing, that this is a Google Collab, right? This is a service that is a Google Cloud service which is provided by Google, and basically here we write our Python codes. Basically what, not Python codes, I tell the data analysis on the sim, because I just you say I just it is very good for using that. Fine, you can just have that thing only, right? So this is a Google Collab, and basically in this I work for data analysis. Fine. So this is the thing, that if I just want to use a library, what I would do, I would firstly import that library. Fine. So that is import numpy as np. Fine. What next? What next? If I just want to use any other library, what I would do, I would write import pandas as pd. Now what is this pd? Pd is basically the library. Sorry, pandas is basically a library that is basically, you can numpy and pandas, they both are used for doing the exploration, like mathematics and all that thing, right? So basically what these do, they perform this mathematical things, right? So for that we use numpy and pandas, and numpy is just, you can say I have written a short form for numpy as np, and I have written the short form for pandas as pd. Fine, this is done. Now what is, I would just do one thing, I would import one more library. So that is import, I would import one more library that we'll be using for the making the scatter plots, that is matplot. Okay, here I would just import a library that is Seaborn, S-E-A-B-O-R-N, Seaborn as SNS. Okay, let's say I have one more library, that is Seaborn. Now what is the Seaborn library used for? This Seaborn library is used for doing the exploratory data analysis. EDA in the sense that it is used for doing and making the graphs. Graphs in the sense scatter plots, bar plots, and bar graphs, and pie chart, box plot, and all that things. Fine, line chart. So the Seaborn is used for doing the exploratory data analysis. Now it is the very first video for this Python, sorry, for this data analysis new data. So here I would just import all the libraries that we would be using further also. So I would just write import matplotlib.pyplot as plt. So basically matplotlib.pyplot, this is also a library only, which we basically use for doing that, performing the exploratory data analysis, that is, it is for use for making the graphs and all that, right? These are the four libraries which we will be using from the you can say for this data. Fine. So let me just quickly run that, and fine, that run. Fine, that is done. Now what is my next step? Next step is that I just want to make a variable, right? I would make a variable in which just I would read my whole data. Now for reading our data, what we use a library that is pandas, and basically pandas is the short form I have written pd, right? So I would write pd dot, okay, so basically what we do, we use pandas for reading, but here we will not be using that thing, because this the data which today I would be taking. That data is like you can say that data is a part of a library, that is the Seaborn library. So here today I haven't downloaded any data, or I haven't taken any you can say website or any link here. What I would do, I would just take a data that some of the libraries have the data on their own. Fine, so I would just take that data for today, so that if you have any you do not face any issue while downloadation or something like that. Fine. So I would write sns dot, I would write load underscore dataset. Fine, and in this bracket I would write. Tips is one of the data sets that the Seaborn library is also already containing. Fine. So what I have written T is equal to sns.load dataset, and in bracket I have written tips. So basically this is the line from where we'll be loading our data and we'll be using this data. Now I just want to check that what are the rows in my data, what are the columns in my data. So what I would do, I would just use a function that is head. Now, what does this head do? This head basically prints the top 5 rows of your column, of your data, whatever the top 5 rows are of your data. It basically prints that. Fine. So whenever I just want to check that what are the columns, what are the things that are in my data, I would just write t dot head. This head is used for printing the top 5 rows of your column. And let's say in the bracket, if you write some number, like, okay, let's say you write 10. So it will display you the top 10 rows. So basically this head function is used for displaying the top rows. Fine. Now this is my data set and it contains some columns like total bill. It has total bill, it has tip, it has gender, it has smoker, it has day, it has type, and it has size. Fine. So these are the you can see columns which my data is containing. Fine. And now here these are the like values, and these are the top 5 one. Now if I just want to check about the last 5, so for last 5 I will use another function that is that was t, right? We were just taking t. So I would use t dot tail, and this tail would print me the last 5 rows. So basically this one contains total 243 rows. Right, 243 rows. My data contains 243 rows. Fine. So this is the way for checking that. And if you just want to check the shape, I would write t dot shape and I would just run that. So it just told me that you have 244 rows and you have 7 columns, right? So this is the, you can say, shape that is 244 rows and it is 7 columns. Fine. What next I have, you can say here I would be plotting my scatter plot, which is the main motive for today. That I would be using the library that is SNS. SNS is a short form from a library that is Seaborn, right? So I would use SNS dot, and here I would use scatterplot. SNS dot is scatterplot. Now what else I have? I would write x is equal to, and in brackets I would just write that name which I just want to be printed in my x axis. Now what were the columns? Columns were total bill, tip, gender, smoker, day, time, and size, right? These were the columns which my tips data was having, right? Tips data was having. Now, if I just want to choose one of them, let's say I would choose total bill, total underscore bill. Let's say I just chose this one. I want that total bill should be displayed on my x-axis. And now, what about the y? I just want that on y, this tip would be there. This tip, that is the column, that is my tip. This tip column, this tip like should be present that side. Fine. So I just wrote tip there. Now, what else I have? Here I need to write the data. Here I need to write the data. Data is equal to t. Here I need to write the data that is equal to t. And that t, what is this t? This is the t in which I am storing my I'm reading my data and I'm storing my data, right? So this is my t. So basically here what I am doing, I'm just writing sns.scatterplot. So basically this is the use of Seaborn library, that is SNS. So this is, I have just given my shortcut, right? The SNS is a short form for writing my Seaborn library. Now what else I have here is scatterplot. So basically scatterplot is used for making, you can see here I want to make this scatterplot. So what I would do, I would write this scatterplot. Fine. Now here what is written, I have taken a variable that is x, right? In x what I have stored the total bill, and I have taken another variable that is y, and I have stored at the tip. Now on my x axis I want total bill to be printed, and on y I want this tip to be printed. What else I have just taken my data, and data is equal to t. So basically t is that variable in which I have stored my data. Now when I would just run this, see, I got a scatter plot here. Now this is how a scatter plot looks like. Fine, this is how a scatter plot looks. So here what I have done, I have plotted between tip and total bill. I just want to see that what is the ratio and what is the proportion for this total bill and tip, right? So I just plotted this scatter plot. I hope you got the idea about scatter plot. Now let's say I have to do some more things. Let's say I would just take t, right? Now I would just perform some things here. Let's say I just want to find that what is the fraction for tip. Okay, so basically fractin. Here let's say I just want to find a tip fraction. What I would do, I would write t, in that t is my variable in which my data is basically read, and this tip fraction, right? What I would just write t, and here I would write t in bracket. I would write my function that is tip. The name of my column that is tip. I would just do this. Here I would write t, and in bracket I would write total bill. I just want to find the fraction for the tips, right? So I would just write total bill, and now when I would run this, it will just basically run. And now when I would just want to find out, I would just run my, you can say head. I would write HEAD and your brackets. Now see, I would be getting one more one more column added, that is tip fraction. And basically in tip fraction, I would be having the values, like the values for which the tip is divided by total bill. So when tip is divided by total bill, whatever are the outputs for each and every row, that are stored in this tip fraction, right? So this is the way for making a new column in your data set. If you just want to make a new column in your data set, this is the way how we do that. Fine. This is done. Now some more features about the scatter plot. So just quickly let me write SNS dot scatter, SCA scatter plot, and in bracket, let's say now I want to just write x is equal to total bill, that is the same. Now what else I want to write? I want to write y is equal to, now I just want to print the tip fraction, fine, FRACTION, fine. So tip fraction is like one of my columns which I have just recently added it here, fine. And now what I would do, I would write data is equal to t. So t is the variable in which my basically data is read. So now just have a quick look over this scatter plot, right? So what are you just like seeing, that the tip fraction is like almost between 0.1 to 0.3. It is almost between that, but some of these are 0.7, some of them 0.4. This also, but main majority is between 0.1 to 0.3, fine. And for total bill, it is between 10 to 30, fine. So basically, this is how we make a scatter plot, right? So this is the way for making your scatter plot. Now, scatter plot has even some more functions in it. Now, one more function is basically here, and that function is known as hue, HUE. Now, what is this basically used for? Let's quickly see that thing also. So I would write SNS dot scatter, scatter plot, right? In bracket, I would write x is equal to, let's say I would write my total bill, total underscore bill, fine. Let's say in y, I just want to print tip. Now, here I would write my data is equal to t, fine. Next and the last thing, I would write HU is equal to time. Now, I just want to check that thing, that it at what time, what is the like basic what is the basic fraction of the tip and the total bill, fine. Now see what it is showing me. It is showing me two different colors, that are orange and blue. Like I hope you just can see this graph that is presented, that is time and your lunch and dinner. So basically this yellow one, and you can say even it is orange, this orange one is demonstrating the dinner, right? And this blue one is demonstrating the lunch, fine. So this is basically how you can add one more function, that is hue. This is one more property of the scatter plots. And yeah, here I just like you just got the point how we make a scatter plot, and basically how we load you can say load a data and what are the libraries needed. Now further what we'll be seeing many more plots basically in this tips data set only, fine. Further we'll be discussing many of these. So for now, just let me give you an overview about the today's video. So it is like I would just import in my libraries which I would be using, so that are NumPy, Pandas, Cbon and matplotlib.pyplot. And after this, as whatever I have written, that are the short forms, right? Next, what I have done, I have written t is equal to, t is one of my variable in which basically I have taken, and what I have done, I have used SNS. So before the previous data which I have taken, that was Google's dataset, in that I have taken PDY because I was having that data in my device only, but this is a data which like this library is containing, that is C1. So if any library contains any data set, so basically we need to use that library short form, that is t is equal to sns.load underscore data set. And here we have tips, right? What else here? I have t dot head. So basically head is used to print top 5, tail is used to print the lower 5 rows. Then I just need to check that what are the shape, basically rows and columns. So I just wrote t dot shape. Now next I have that I need to print that, I need to see what is the scatter plot. I want to make a scatter plot. Fine. So it is SNS dot scatter plot. X is equal to total bill, Y tip, and data is equal to T. Right. So this was the thing. And now if you just want to add one more column in your data, what you do basically, we make one more column, something like this. We write the name, that variable name, that is T, and after that in the brackets we write that column name which we want to make, and we write that the values which we want to store. Fine. So this is done, and after that this is the way for writing the hue function also in the scatter plot. So now I hope you just got the all points about the today's video, whatever we have discussed, and this was the basic that how we make a scatter plot. I hope you got all the points. If you have any doubts, you can ask that doubts in the comment box, or you can even rewatch the video. So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi, and today we are going to discuss some more tricks and tips about the scatter plots, right? So basically in the last video what I have told you about the library, that is C1 library, and from that what we have seen basically that how we can just plot some scatter plots using that library, right? So these are the things which we have discussed in the last video. So for today we are just going to see some more features of the scatter plot, and after that what we are going to see, after that we are going to see one more plot, and that plot is known as reg plot. Okay, so just we are going to deal with both of these things today. Okay, so let's start writing. So firstly I would write SNS. So basically what is this SNS? This is the short form for writing my C1, right? So basically in the above side, okay, just let me show you that thing. Here what I have written C1 as SNS, right? So basically this means that here I am just using my C1 library, and I'm just giving it a short form, that is SNS. Okay, so I would just write that thing here. I would even write SNS dot. I would just try to make this scatter plot, right? So I would just write plot. Fine. This is my SNS dot scatter plot. What else I have? I would write X is equal to, and here I would just give the column that is total underscore bill. Okay, so basically total underscore bill is my column which I have just given here, right? Now what else I have? I have Y is equal to, okay, now it was another column. Just let's go above and verify the things. So these were the columns which I was having, and yeah, after doing some operations, what we have done, we have just made one more column, and that column was tip fraction, right? So I was having total bill, tip, gender, smoker, date, time, size, and tip fraction. Fine. So these were the columns which I was having. Now here I have just given the name for my X column as total bill, and for my Y I have given here the value as tip. Now what else I need to do here is that I would just write data is equal to, right? So if you have just in my previous video for the same thing, so you have just got an idea that basically how we make the scatter plots, right? So here just I'm telling you that thing only. Now here I would just add that hue. Okay, hue means that basically it should just gives us a different colors. Okay, just let me show you that same thing. Okay, fine, I would just run this thing. Okay, now just have a look that here whatever the circles like small dots I have, they are in different colors. So basically I was having the smoker as two conditions, yes or no. So basically this is a tip status, right? So there it was like something that do you need a smoker or right? No. Okay, so they was having two conditions, yes or no. That is why my graph which I have just made here, that turned blue and yellow, that the dots which are present, they are in two colors, that are yellow and blue. Sorry, that you can say just orange. Okay, orange or blue, right? So I hope you got the idea about this scatter plot, that is SNS dot scatter plot. And here hue is equal to smoker. Now let's see if I just want to change this hue. Okay, I just don't want to write this. I would just take it to days. Okay, so I would write SNS dot scatter plot, and in the bracket I would write X is equal to total bill, total underscore bill. Right, now what else I would write? I would write Y is equal to, here I would write tip. Fine. What else I would write? I would write data is equal to T. Fine. I would just even write hue is equal to, and here I would just put day. Fine. So basically this is the way that basically you can even add this another thing. And here what I have now, okay, just let me stay here only. Yeah, so what is this? Is hue. I have just put the day. So the days which are present in my data are Thursday, Friday, Saturday and Sunday. So according to that only the colors of my scatter plot change. And yeah, you can just have a little bit of look also, that basically the highest tip that was given on sending, highest bill, and even the highest tip, right? So on sorry, that is Saturday, green is Saturday. Fine. So this is the main idea about this using the scatter plot. Now I even have some more parameters in the scatter plot. So what I would do, I would write SNS dot, I would write scatter plot, and inside this I would just give x is equal to, let's say I'm just going to work all of the things above my total bill only, right? Okay, I need to just give these brackets here. I will just write t, and I will just close this bracket also, fine. What x, like I have given the value for x. Now I will just do the same thing for y. I will just write, okay. Now what else I have? I will write data is equal to t, fine. And next what I would write, I would just write hue, okay, and HUE, and hue is equal to, what else I would write? Let's say I would just give the hue as size, null size, okay. Now let's quickly run that thing. And yeah, like it's taking a little bit time for the, okay, fine. Here I got. So basically the size just means that the what is the family size, right? 1, 2, 3, 1 member, 2 member, 3 member, 4, 5 or 6 members, right? So this is the respective of the size. So basically here we can just have an idea of the total bill, that basically what is the total bill of the family size, fine. So here the colors denote the family size. On the y-axis we have tip, and on the x-axis we have total bill. So from this we can just come to a conclusion that okay, this much of family members are costing this much and they're just giving this much of tip. Fine, so this is the whole idea about this. Now even we have one more parameter, that is style. So for that, just let me write that scatter plot once more. I would write scatter plot, and I would write x is equal to total bill. Fine? Total underscore bill. Now what I would do, I would write y is equal to, and here I would write fine. Now what I would do, I would write data is equal to t. What else I would do? I would just write hue is equal to, let's say I would just put that size only. Now here my next parameter comes, and that parameter is a style. Okay, I would write style, and here I would just write, okay, I would just write, okay, gender, fine. So here I will just quickly run this program, and after running it, just let's see that what's the output we are getting. So here what I have done here, this color dot, okay, this is denoting the males, and this cross that is present here, this is denoting the female. So here we can just have an idea about that, how many males and how many females come to just this hotel, and what is the like total bill, what is the total tip, and what is the size of the family, and all that things we can just have a guess from this side. Okay, we have this parameter, that is style, fine. Now what next I have, next I have just written, now I just want to add one more parameter. Now I want this thing, okay, let's have one more thing here. I would just write okay, I would write SNS dot scatter plot. Okay, SNS dot scatter plot. What I would write, x is equal to total underscore bill. Okay, this is my total underscore bill. Then what I would write y is equal to, what I would write, data is equal to t. Fine. Now what else I would write? I would write hue is equal to d. Let's say we just add hue is equal to size. Okay, size. What else I was having? I was having style is equal to, okay, so I just put one extra this side, and yeah, okay, so style is equal to this. And what next I have? Next I have here one more parameter, and that parameter is size. Okay, the size is equal to, and I even want to just put that size only for my this thing, and I will just run the program. Now see what output did I get here. So, fine. Now you can just have a look that like whatever the you can see the circles are there, they are little big, small, and something like that, right? So this is the basically whole idea about putting these parameters. Now what else I have? I have this box present here this side, right? Now if I just want that this box should be present at this corner, because like it is coming in between the you can say data, right? In between the plot it is coming. So what I would write, I would just firstly write the code for the scatter plot, and next I would add some more parameters. So just let me write SNS dot scatter plot. In bracket I would write x is equal to total underscore bill, right? I would write y is equal to, then I would put the tip. Now what I would do, I would write data is equal to t. Fine. What I would next write, I would write hue is equal to size. Fine. Now yeah, hue was size. Now what next I would write? I would write style is equal to this. And next what I would write? I would write size Yeah, size is equal to size, and here I would just do enter, and here I would just use my plotly library, matplotlib.plotly, which we have just pronunciated as plt, right? I would just go up in our little and just show you that thing. So I would write plt dot, this legend is one of the functions which is like, here you can just get a look that basically why we are using this. So I would just write here bbox underscore okay, bbox underscore 2 and underscore anchor. So basically this is used for shifting of the thing which I just told you, and here I would just put this, and here I would just write 1.05 comma 1. Okay, and I will just put the semicolon this side. Now as soon as I will run my program, now see, now have a look that the like this box which I was just saying, now this box has come to out of my scatter plot. Okay, so this is the main idea about using this plt.legend bbox to anchor. This is basically used for changing the, you can say it was just present this side. So here I just give some dimensions and it had just brought this box to this side. Fine. Now let me go above once more. Yeah, so this was the library which I was talking about, that is import matplotlib.pyplot as plt. Fine, so this was the library which I was talking with you, that I have like downside when I just use that legend here, or just let me go to that side only. Yeah, here where I have just used this legend, so I have used it with the plotly library, that is plt. I just showed you that I have given the short form from matplotlib.pyplot, right? This is done. Now I was just talking that we will just be dealing with one more plot, that is reg plot, right? So now just let's quickly plot that also. So I would write SNS dot reg plot. So it is reg plot, okay? REGPLOT, reg plot. Now what I would do, I would just put this, and let's say I would just add some columns. So let's say here I would be taking the same one which we were dealing before, and that is total bill. Fine, I would just put a comma. I would write y is equal to, fine. Now what I would do, I would write data is equal to t. Fine, so these are the things which are just done here, and this is over. And now when I would just put this column, and now when I would just run that, the semicolon, okay, semicolon, yeah. So this is my plot which I just got here, that is reg plot. So basically this reg plot is the one which just shows us a line also, right? So that I just have a line also this side, fine. So it just basically gives us a perfect line for a plot which we have just plotted, fine. So this is done. Now if I just want to change my values, I would write SNS dot reg plot, and here I would write x is equal to total underscore bill. Fine. Now what I would do, I would write y is equal to, and here I would just give one more, that is tip fraction. Okay, tip fraction. Now what I would do, I would write data is equal to t. What else I would write? I would just run. So here I have just changed the things, and now you can just have a proper look that basically my graph has also changed. So when I was just doing this thing, when I was writing y is equal to tip, so my line was like upside, right? It was just going upside. Now when I'm just writing this tip fraction, so basically it is going just downside. Fine, I hope it has got the idea about this reg plot, and basically reg plot has one more parameter, that is SNS dot reg plot, and basically here what we have, x is equal to total underscore bill, right? Now what else I have y is equal to tip fraction, okay, tip underscore fraction. My data is equal to t, and I have here one that is marker, right? So marker is basically used for changing the dots like these circles to the another sign. So let's say here I just put the, okay, so like it is showing me some error, that basically marker is equal to, okay, I just missed one equal to sign, and now let's quickly run this once more. Basically now here you can just see that basically before what I was getting these circles, right? Now what I am getting these plus signs. Okay, so I hope you just got the point about the tip fraction, like total bill, that basically how we plot this scatter plot and these reg plots. So today here we have completed the understanding that basically how we make scatter plots, all the parameters of the scatter plot we have discussed, and basically we have discussed about reg plots. Now we'll move further towards this tips data only in the next video. So I hope you just got the whole video. So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi, and today we are going to discuss about two more plots, and they are basically named as line plot and bar plot. So quickly let me give a recap that basically in the last videos what we have discussed. So in the very first part of this data analysis for tips dataset, we have just discussed about the libraries, right? They were NumPy, Pandas, Seaborn and matplotlib.pyplot. And even we have given the short forms to these. For like just hold on, let me just zoom in a little bit so you can have a proper idea about this. Okay, now it's fine. Okay, so in the first video we have just discussed about the libraries which we have just initialized, and they were just NumPy, Pandas, Seaborn and matplotlib.pyplot. Then moving forward, we have just like read the data and seen that what were the rows and columns in our data. We had seen the shape, then we had plot the scatter plots, and after that we have just added one more column, that was tip fraction, right? And followed by we were discussing scatter plots, and basically in the second video also we have discussed some more features about the scatter plot, and even we have just discussed about the reg reg plot. Okay, so this was the thing which we have discussed till now. Now moving towards for today's video, we are just going to discuss about the bar plots and line plot, that basically what are these two plots, and using the Seaborn library basically how we plot these things. Okay, so we are just going to discuss these things. So let me start writing. So I will just write there SNS. So basically this means that short form for my Seaborn library, and that is SNS. Okay, so in the above in the above we have like initialized imported the library, that was Seaborn, right? So I have written import Seaborn as SNS. So SNS was the short form which I have given to my library, and the library name was Seaborn. So that is why I'm just using SNS dot, and firstly I will just plot the line plot. Okay, so I will just write line plot. Now here what data I'm going to take, my data was stored in the variable that was t. Okay, so I would just write data is equal to t. Let me quickly show you that thing, that basically data was written in the t. Okay, so here we have just taken the variable t, and just we have load and like read our data in this variable that was t, right? So I have just done that thing only here, and I have written that data is equal to t. Fine. Now what I would do, I would just take my x and y axis. Fine. So firstly I would just take my x axis. Let's say firstly I would just take the same axis which we were taking basically for the scatter and basically for the reg plot. Okay, so I would just take total bill. Okay, so total underscore bill. And what next we were taking? We were taking y is equal to total, that was tip fraction, underscore fraction. Fine. So this was the thing which we were just taking. For the x was the total bill and y was the tip fraction. And here we have just plotting the line. But now quickly let me run that thing. So after running, see here what did I got? I just got a little bit of like, this is how a line plot looks. So this is a like not a very clearer idea, but yeah, this is a like a little bit of idea that basically how this line plot looks. Here what I have taken tip fraction and total bill. So that is why it is looking little bit of messed up, because like data values are much here. That is why like here in the between the plots like and the lines, these are messed up. But when we are just going to take higher data in the sense like the data which is clearer, then it will not be like that. Okay, so I would just take another example and show you that how we can just do that thing. So I will just write SNS dot, I would just write here line plot. Okay, and now let's put the brackets. Now inside this bracket, let me tell you that we can just take data is equal to t I taken. Okay, now what I have done, I have just taken x is equal to, I would take day here. Okay, x is equal to day. What else I would do? I would do y is equal to, and even I would just write here size. So y is my size, x is my day. Now what next I would do? Okay, so for now let me plot these things only. Okay, so now just let me show you, and now you will have a clearer idea at basic excuse me, that basically how a line plot looks like. Okay, so this is how a line plot looks. You can just see one like a straight line this side. So here what I have just done, I have taken on my x as day, and on y I have taken size. Okay, so one thing here is that for this line plot and even from all of the plots, we need one numerical value. One numerical value is compulsory for plotting any type of plot. Okay, so that is why here when I have taken one categorical and one I have taken numerical values. Fine. So this is basically how a line plot looks. Now there are several many features inside this line plot also. So just let me quickly tell you all of them. So here I would just again write SNS dot line plot, and even I would just write data is equal to t, right? I would just take x is equal to, we are writing day, right? And what I would do, I would just write y is equal to, and here I would just write size. Fine. Now what I would do, I would take hue also. Now here hue is one more like parameter which we can just take for a line plot, and that is hue. which is equal to time. Now what is this hue? Basically I have explained these things in the scatter plot itself in very detail. So if you just want to have a look, so you can just go and have a look over that side for the hue. So see, now here what did I got? I just got a small box here. Let me just zoom in a little bit more. I'd like, okay, fine. Now I hope it's totally fine. See, so this is the basically plot which I am getting here. Now here the things are that there is one box, right? This box, what is this? Here is written, it is written time. And now here lunch and dinner. So basically now from our data set we have taken the variable that was time. So in time we are having two times, either it was lunch or it was dinner, right? So here lunch and dinner. Now lunch is denoted by a blue color line. So here in this plot you can see one blue color line, right? And one line is for orange colors, right? So in the this orange is for dinner and this blue is for lunch. So basically this depends on like size is the number of family, size is the family members, are basically how many family members from a particular family are coming to arrive to like have a dinner or lunch. So basically this is about the size, and here we have written day. So it is like plotting me that okay, like on which day what how many family members came to lunch, how many family members came to dinner, right? This is the whole idea about plotting this kind of box plot. Let me now zoom out again. Fine. So this was the parameter, and now we are just left with one more parameter from this line part. So let me quickly write that. I will just write SNS dot. Okay, I just wrote line plot, and here what I would do, I would just write data is equal to t. Now what I would do, I would just write x is equal to, and here what I would write, the variable which I was taking, that was day, and I would just write y is equal to what I was taking size. Fine. I would just write size. Now what else I would do, I would just again write that hue also. Hue is equal to time. Now what else I would do, I would just take one more parameter here, and that parameter is style. Okay. Now according to style, I would just write in style also, I would just declare as time. And now when I would just run my program, see. Now here what did I got? Now match it from the above example. That above example I was getting both of the lines as straight lines, right? But here in this one example, what I am getting for the lunch time I'm getting the straight line, but for the dinner time what I am getting the dotted lines, right? So this is the basically difference when I just wrote that style. So basically whatever the variables or whatever the different things would be present in this time column. So in time what we have lunch and dinner. Let's say here it was like breakfast also, okay? Breakfast, lunch and dinner. So it would be in three different style of lines. So one should be like straight, one would be dashed, and some like dotted and something like that, okay? So this style parameter does the thing that it basically gives the style to our to the lines which are just present here according to the number of variables given to it. Fine. So this was the idea about the line plot. Now let's quickly move towards the bar plot. Now we are just going to discuss that basically how we make a bar plot using the Seaborn library. Fine. So here I would just write SNS dot bar plot. Okay. Now the I would just take data is equal to t. Fine. I would just write a column name for x, and even I would just do the same thing for y. So for y, I would just write the size. Now when I will just run my program, so see, now what it just gave me, it gave me that okay, this much was the family size, and according to that family size, this much males were there and this much female were there. Okay, so this was the whole idea about this data, that basically according to the family size, how many males and basically how many females were present in that the tips of the data set, right? So this was the whole idea about that one. Now there are several more parameters in this bar plot also, so let me quickly discuss that thing. So I will just write SNS dot bar plot, and inside this what I would write, I would just write data is equal to t. I would just define my x as the same which I have like defined above. I would just write y is equal to size. Okay. And what I would do here also, we have the parameter, and that parameter is hue. Fine. I would just write hue is equal to, I would just write time here, right? I would just run my program. So now have a look here, decide that basically what I got here. So I got that in lunchtime and dinner time. So basically here what I am getting, that how many males and females are arriving at lunchtime and dinner time, and like according to that only I'm just getting the whole idea about my like about my data. So basically from here what I am like, I can conclude from here that in according to this data which I am getting, according to size and the gender which I have, so here male. So like the ratio for the male going at dinner is like high, okay, and the ratio for the male going at lunch is low, and like almost for females the ratio for going in lunch and going in is dinner is all like basically same. So this blue one denotes the lunch and this orange one denotes the dinner, right? So this is the idea about plotting this bar plot. I don't know like you are able to see or not, so just let me zoom in a little bit more, and here you can just see that basically like below here one box is present, right, and that is basically telling me that which color is like which color is for which one. So blue one is for lunch and the orange one is for dinner, right? So from here I can just get an idea that basically this is the excuse me, whole thing about this data. Now even I have some more parameters about this, I would just write that one also. So here I have just written that, fine. Now I would just like 1 second, okay, fine. I would just write here SNS dot, and we are just making the bar plot, right? I would just write bar plot, and here I would just write data is equal to t, okay. I would just write data is equal to t. I would just write x is equal to, I would take the same column. I would, for y also I would take the same column which we have taken above. Now here I would just write the hue also as same. So hue is equal to time, fine. Now what else I would do? Now here in this bar plot what we have a parameter that is called as palette. Now what does this palette do? This basically helps us to give a particular color to our bars which are just present here. So like in the above what you have seen, in the above lunch was having blue color and dinner was having orange color. Now what if I want that my lunch should have light blue and my dinner should have dark blue, something like that. So basically there what we give a new parameter, and that parameter is palette, right? So inside this like parameter what we give the colors, that basically which color you want. So when I will just run my program, so like it would take a little bit time, and just let me run that thing. So like according to your internet connection what it will do, it will basically result to the output, fine. Okay, so just let me go above. Yeah, so you can just have a look here that the bars which now I am having, they're having light blue and dark blue color. So light blue color is for the lunch and the dark blue color is for the dinner, right? So this is the idea about changing the colors of your bars which are basically present in your data set, fine. Now even we have one more and the last parameter for this, and that parameter is SNS dot. I would just write bar plot. Here I would just write and take the same columns which I have just taken previously. I would just write the same for y also. I would just write hue, okay. I would just write hue is equal to, I would take time, and what else like I would just declare that palette also, okay, PALE, and that's okay, PA, okay. So what it is saying that basically automatic document, okay, let it be, afterwards I will do that thing. Okay, so palette is equal to, and it was blues, right? BLUES, and afterwards what I have estimator. Estimator is one more parameter which we have. Now what it does is then I would just write here np dot median. So now what it will give, it will just let me know about the median of the bars which are just presented. Let me run that thing, fine. So basically it will take, okay. So what it is saying that it cannot, okay, so I just missed writing my data here. So data, okay, median, MEDIAN, I would just write here as data is equal to t, and I will just put a comma this side. Now it's fine. Just let's quickly run that thing, and yeah, so after running it would just result me the output with like whatever the output which we will be getting, okay. So like it's taking a little bit of time due to my internet connection, and yeah, due to that only it is just taking a little bit of time. So here we like what I would be getting, I would be getting this like the dash which you are saying, right? So they would be just showing me about the median of that respective, right? So just let me see that, is that over? Okay, fine. Yeah, so now you can just have a look that basically the bars for both of them are same, but here what I am getting the median, right? So this bar, this small one, this is a median, fine. So this was about discussion of the line plots and bar plots which we have just discussed today, and we have even discussed about several parameters which we can just include in this line plot and bar plot, right? So I hope it has got the whole idea about discussion of this line plot and bar plot, and basically what are the parameters which you can include, and basically how you can make these line plots and bar plots, right? So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi and today we are going to discuss one more plot on the tips data that we were just doing previously. Today we are going to discuss about the cat plots. Okay, so cat plots are one type of plots that are basically involved in the Seaborn library. So these cat plots are under the Seaborn library, and just we are going to see that basically how we make that cat plots. And inside that cat plots, we have even some more plots, right? So we are just going to see all of that things today. Fine, so let's get started with the things. So let me give you a quick recap that basically what we were doing, right? So let me just zoom in a little bit more. Fine, now I hope that you can just see the things very clearly. Fine. Okay, so the first thing is import numpy as np. Okay, so these are the four libraries that we were using. So the first one is numpy. Moving forward with the pandas, Seaborn and matplotlib.pyplot. Okay, so these were the four libraries which we were just dealing with, and they were we were seeing and retrieving some data, doing some exploratory data analysis using the libraries. So for now, I have used my Seaborn and matplotlib.pyplot, these two libraries, for doing all of the data analysis, all of the exploratory data analysis, making the plots using these libraries, Seaborn and matplotlib. Fine. So let me just quickly give you an overview that basically if I have written something like import numpy as np, so that means numpy is my library which I am importing in this particular notebook which is in Google Colab, and what I am just giving, I'm giving a short form to this library, and that is np. Fine, so I have written just import numpy as np. So that means numpy is the library which I'm just using, and np is a short form which I'm just giving to this particular library. Moving towards the pandas, we have import pandas as pd. So this is also same. I'm just importing the pandas library into my this notebook, whatever I'm just using right now, and I have just given it a short form as pd. Okay, so I just give the short form because each and every way I do not need to write pandas and pandas.read, pandas.retrieve and all that thing. So I just use a short form that is pd. I can just use this pd anywhere, and I can just write the program. Fine. So this is the shortcut for giving a name. Same for Seaborn. So for Seaborn I have just given as sns, and for that matplotlib.pyplot I have given plt. Let me quickly tell you the data which we are dealing with is a tips data that is already in a Seaborn library. So basically I have not downloaded that data in my device. So basically what we can just use for reading that data, and that is t is equal to sns dot load underscore dataset and the tip. So here I haven't used pd, that is pandas. Why? Because my sns module, the module which I am using here, that is Seaborn, and the short form that is SNS, so that is already having the data stored in it, that is tips, right? So I need not to use pandas for that. So I would just be using that library in which this data is stored, and that is Seaborn. So that is why I just use this SNS instead of PD for reading my data. Fine. And after that, these were the things which we have done. So I will just give a quick recap to all of you at the last of the video. Fine. So, okay, now today what we are just going to do, we are just going to see the cat plot. Okay, I'm just going to tell you that basically what are these cat plots and how we make this cat plots. As I just told that under this cat plots, we several other plots also come. So let me quickly give you all of the things. And before that, what I'm just going to do, I'm just going to write something about cat plot this side. Okay, I'm sorry, just write as text. And I would make it as bold, and I would just write it in a little bit smaller handwriting. Fine. So let's start writing with me only. Okay. So I would just write this is a function. Okay. This is a function, not this function. Fine. This function provides access to several access level functions that show the relationship between a numerical and a categorical data. A categorical data, you can just take it as categorical variable. I have already told that what are the numerical and what are the categorical variables in my previous video. Okay, so now not now, I'm just going to tell you all of these things. If you just want to like see that what is the numerical data and even what is the categorical data. So what you can just do, you can just go to my previous video and there you can just have a look about categorical and numerical one data. Okay, so this function provides access to several access level functions that show the relationship between a numerical and a categorical variable. Okay, I need to give the spaces. Okay, using one of the several visual representations. Okay, our EP RESCNTATIONS. Fine. Okay, what I have written here for my cat plot is that this function provides access to several access level functions that show the relationship between a numerical and a categorical variable using one of the several visual representations. Okay, now just let me tell you that basically what I just mean from here. Here in this cat plot, we have a parameter. That parameter is called kind. Now, this kind parameter, basically what it does. So this kind parameter is kind of a parameter in which basically I can just pass that which kind of plot do I want. So as I just told, that cat plot is one of the plots. Under that cat plot we have like sub many plots, right? So if I just write that I want box plot, so I would just write kind is equal to box, and like that will just demonstrate me the box plot. Let's see all of these things while doing the example. So I would just write SNS plot, and here I would just write the plot which we are going to make today, and that is called cat plot, right? SNS.cat, but I will just put the brackets. I would just write data is equal to t. Okay, so above side also the data which we have taken, that data was t. Okay, so we have stored the data in the variable, and that the name of that variable is t. So I'm just writing here data as t. Now what I am just going to give here, firstly I'm going to give the kind, that what kind of plot do I want, fine. Let's say here I would just give you like demonstrate an example for the kind, and let's say here I just take the kind as bar. I would just not take bar because bar plot we have already discussed, so I would just like show you that afterwards. I would just discuss a new type of plot, and that is swarm plot. Fine. I have just given kind is equal to swarm. Okay. So this means that under this cat plot we have a type of kind, and the kind is swarm. So I just want the plot that is swarm. Fine. The kind for that plot is swarm plot. Fine. Now what else I would just write? I would just give the values for the x and y axis. So I would just write x is equal to and y. And let me just go above and let's see that what are the different rows and different columns which we are having, and I will just see here. Okay, so I have total bit, tip, genre, smoker, date, time, size, and tip fraction. Fine. So I would just take 2, 1. On X I would just take day, and on Y I would just take total bill. Okay, so these are the two columns which I am taking, one categorical and one numerical column. So on X I would just take as day, and you can just change these things also if you just wish. For now I'm just doing the same. And I would just write total underscore bill. Fine. So on X I have taken day, and on Y I have taken total bill. Now what next? What next I'm just going to do? Here, okay, I will just give that hue afterwards. For now I'm just writing this thing only, and I will just run the program. Fine. Okay, so here what did I got? I got the like plot between total bill and the day. So these are Thursday, Friday, Saturday, and Sunday, right? So these are the days, and basically this is the total bill, amount of the total bill. Fine. Now this is a kind of a plot which we can say, oh, this is a swarm plot. So this is how a swarm plot is made. Now what does it refer to and what does it mean? We will discuss all of these things in detail in further videos, but for now I would just like to tell you that this plot is called a swarm plot. This is how we just make a swarm plot, right? I just wrote this thing here. Now I just want to like add one more parameter here, and that parameter is hue. Okay, so you all know that what is hue parameter, right? I have already described this thing in very detail in my scatter plot and REG plot videos. Okay, so if you haven't seen that, just go quickly and have a watch over that video. There you just get to know that what is this basically hue parameter. Fine. So here I would just again write SNS dot, and my plot is cat plot, right? So I would just write cat plot. In bracket what I would just give, I would write data is equal to t. Then what I would just give, I will just give kind is equal to swarm. Okay, so basically why I just rewrite all of these things again and again, and why do not I copy? Because like I never copy, even this from my code also, I just never copy the things. Okay, so that is why I just like write the things on my own. And this thing I would just prefer you also you should also not copy the above code whatever you have written. You should just write that on your own so that you can just learn the syntax. You cannot sit on a day, like let's say this Sunday, you can just sit on that day and you just like start learning. Okay, cat plot, then the data is t, kind, then x, we have x column, we have y, then we have hue parameter. No, the things will not work like this. Fine. So you need to just practice and practice more. And while writing again and again and again, you will just get a whole idea. You will just learn everything in a very easier way, and you will never forget that thing. So that is why I just write each and everything again and again. Fine. So this is like I'm not going to give like do my benefit. Fine. While writing this. Okay. So data is equal to t, kind is equal to sum, x is equal to d. On x we have given the column that is day. I had written y is equal to total bill. So total underscore bill, and now what I was telling you about, I was telling you about the hue parameter, right? So I would just write hue is equal to, and here I would just let's say I just write smoker. Smoker is the hue which I just wanna give. Fine, I will just run the program. Okay, now you can just see the difference between both of the plots. So in this plot, what I was having 4 colors, blue, orange, green, and red. But here what I am having only 2 colors that are blue and orange. And it basically shows me that on this particular day, these were the bills and these were the smoker was yes and smoker was no. Wherever we just see the blue colors, that means the smoker is yes, and wherever we see the orange color, that means smoker is no. Fine. So this is the idea about making the swarm plot using this cat plot, and basically like giving the kind as swarm and basically using the hue parameter also inside this thing. Okay, so this was about one. Now what next plot which I'm going to tell you is the violin plot. Fine. So violin plot is one of the more plots which you basically use for plotting seeing the data analysis. Fine. So I will just write that thing also. SNS dot, here I would just write cat plot. SNS dot cat plot. In the brackets, what I'm going to write? I'm going to write data is equal to t. Fine, data is equal to t. Then I would just put a comma. Then I would just write kind. Now inside this kind, what I am going to do is that I'm going to write the violin. Okay, so that is VOILIN. Okay, so this is the kind of violin. Now what I'm just going to do, I'm just going to plot a violin plot. Fine. Next, what I have, I need to give the x and y values, and I'm going to give the same values which I have taken above. Fine. So I will not confuse you while taking different values. No, I will not do that thing. I will just plot all the cat plots in a very same columns. Fine. Total bill. And what else I have? Okay, fine. So I will be just taking the 2 more functions afterwards. Fine. Okay. Okay, so it is saying that plot kind value is not recognized. Okay, so have I just made any mistake or something like that? So kind is equal to 1. Okay, let me just do one thing here. What I would do, I would just take the hue also. Okay, hue is equal to smoker, SMOKER, and what next I have? I have split. Split is one of the parameters which you basically write in this violin plot. So I would just run that thing. Okay, so it is saying me that plot kind violin is not recognized. Okay, I had made some mistake. I just get the thing. So VOILIN spelling is absolutely fine. And what's the issue? X is equal to D, Y is equal to total bill, hue is equal to smoker, split is equal to true, and the data is T, right? Data is also T. That is SNS dot cat plot. Okay, let's see that. What's the basically issue here? Okay, sorry, the spelling is wrong. Sorry. I'm so sorry for that. VIOLIN. Okay, VIOLIN. I just was not able to see that thing that I'm written as wrong spelling. Fine. So now here the program is run, and yeah, now you can, I would just remove these 2 for now. So that I can just tell you the difference. Okay. So I will just tell you the difference, that what's the difference while writing these things, and let me just erase these things. Fine, let me now run that. Okay. So now here you can just see that you have just got these 4 here, right? And these 4 are of different colors. Now what is we are just plotting here? We are just plotting about the total bill and the day. We're just plotting the violin plot. So this is a kind of a violin. Okay, so this is a kind of violin. So that is why it is called as violin plot. So here we just did that thing. I just plotted the things. Now there are some more parameters which I can just add in this. So let's quickly do that thing, right? I would just now do the things here itself. Okay. So here we would just firstly write split. Okay, SPLIT. Split is equal to true. And now I just run the program. Okay, so this is basically like a splitting of my violin plot. Split is equal to true. And what next I have the hue. Okay, hue I will just give as same which you are taking. Hue is equal to smoke. Now let me quickly run that thing. Okay, fine. So now here you can just see that my all of the violins are just converted into two colors, that are blue and that are orange. Okay. So the blue one demonstrates the yes, and for orange we have no. Smoker yes and smoker no. Fine. So this is about the violin plot. So this is how a violin plot looks, and basically what are the things which are just here. We will not go into that things right now. Right now, what's my basic motive that I should tell you all of the plots which basically the Seaborn library contains. After that, we will just see each and every plot in a very detail that what does this plot mean and like basically what are the things in this plot. Okay, so if you just want to get an idea of the box plot, so for box plot I have already made the video in the statistics playlist. So the video for that is already in the statistics playlist, so you can just go and have a look there. Okay, so this was about the violin and the okay, so violin and what was the first one? Swamp plot. Okay, violin and swamp plot. So these were the two plots which just consist under the cat plot. Now, other than this, we have just bar plot, we have a strip plot, we have box plot, and we even have a point plot. Right? So these are the four plots that are left under this cat plot category. So I would be covering all these four plots in my next video. Right? So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi and this is the part 2 for the cat plot which we just seen. Okay, we were just seeing the cat plot, that what are the subplots which we have inside the cat plot, and this is the part 2 for that specific video. So today I'm going to tell you the rest the rest 4 to 5 plots which are just left for that cat plot. So I'm just going to introduce you to them and show you that basically how we can just make that plots within using the Seaborn library, right? Let me quickly give you a quick revision that we have imported 4 libraries and these were NumPy, Panda, Seaborn and matplotlib.pyplot. Okay, and even we have given the short forms to these libraries and they were just followed as NumPy, PD, NP, PD, SNS and PLT, right? I'm not gonna give all these things in very detail because I have already told this in detail in the very first part of this video. As for the cat plot, I have just in the first part for this cat plot, I have told everything in very detail. Okay, so I'm not going to repeat that things right now. Let me quickly go to the downside and here what I'm going to tell you. Okay, so this was the definition which I just told you something about that cat plot. This function provides access to several access level functions that show the relationship between a numerical and a categorical variable using one of the several visual representations. Fine, so this was the definition which I just told you that basically what is this cat plot used for, right? And then what we have seen a cat plot for the swamp. The kind for this cat plot was swamp. What next we have seen? Okay, hold on, just let me go down. Yeah, so next which we have seen was the violin plot. Okay, so the spelling I had made wrong in the last video, that was violin. So you also just keep that thing in mind. Okay, now let me quickly start writing the things for today, and today I'm just going to discuss 4 which are left. The first one is the bar plot, second is strip, third is box, and fourth is point. Fine. So I'm just going to discuss all of these things today. Fine. Let's get started by writing. So I will just write SNS dot, and here I will just write cat plot first. Okay, SNS dot cat plot. Now inside this brackets, firstly what I'm going to give the data, right? So the data in which I have read my data from the Seaborn library. So the variable for that is t, right? So I will just write data is equal to t. Now comma. Now x is equal to okay, so here firstly what I would just give, I would just give kind. Okay, so I would just give kind is equal to bar. Now for now I would just firstly make the kind to is equal to bar. So basically what I would be getting, the cat plot, the output for the cat plot in the form of bars. Fine, that is fine. So kind is equal to bar. Now what next I have basically here, next I have that I need to just write x and y x's. Okay, so I would just put a comma, I would just write x is equal to, I would just take as the same which we were just dealing, because I don't want to confuse you while using different columns for now. We'll be just seeing different columns and more things in the further videos. Okay, so here I will just want to give you a proper idea that basically what is a cat plot and what are the kinds which you can just include in this cat plot. Fine, so x is equal to d, and what I just write for y, I will just write as total bill. So it's total underscore bill. Now, so this is done. Now what I would just use, I would just score, like I would just run that. Fine. So here what I have. Okay, so here I have these 4 bar plots and they are basically total bill and day. Fine. So these are the bar plots, like bars which I am having, which are like used like basically. This is a cat plot and that is basically represented in the form of the bars. You can just see all the things like that. Fine. Now what next I have? Next I have like okay, so one parameter is just left. Okay, let me quickly go to the previous bar plot which we have made. Okay, so you can see that this is the bar plot basically in previously whatever we have made, right? But now here what I have just changed, I have changed even the values and even the like everything is changed for this, fine. Now we have one more parameter in this kind is equal to bar. Let me quickly show that. So I will just write sns dot and cat plot. So basically the ones who are just seeing my video from the very starting and just following all the series, you must have guessed that what will be the next parameter which I'm just going to tell. And yeah, I just hope that you have guessed the right thing. So data is equal to t and I will just write firstly as kind. So kind is equal to bar. Fine. Now what I would just write, I would just add x. So x is equal to, here I would just I would add day. So that is day. Now I will just write y. So for y, what I would just do, let me do one thing, like let me just zoom in a little bit more, I hope. Right. So now I hope it is more clearer and more finer, right? So x is equal to day and y is equal to total underscore bill. Okay, and the parameter which I was saying, that is not smoker, that is hue, and hue is equal to smoker. Okay, now we'll just run that. So here what just I get, now you can see the like all the bars which I am getting, they are basically divided into two things. One, the blue one is that smoker is yes on this particular day and the total bill is this much, and basically the orange one is no, that no, the smoker is not and the bill was particularly this much. Fine. So like this is the idea about plotting this bar plot. Now so this was about plotting this bar. Fine. Now what I would just like take next, I would just like next I would take as, okay, I would be just dealing with strip plot. Now strip plot is one of the next plots which we are just seeing. So sns dot cat plot. Okay, I would just write here as data is equal to t. Now I would just add kind. Okay, so kind is equal to, and I would just write as strip. Okay, I will just put the semicolon strip. Fine, I would just give the x and y value. So the value for x would be day. Fine. And the value for y would, okay, I would just write here as y is equal to, value for y would be total underscore bill. This is okay. Now what next I have? Next I have, yeah, that is all. Afterwards I would just add that smoker function, right? So this is basically how we make a strip plot. Now let's quickly see that what's the difference between the swarm and the strip plot. So inside the swarm plot we have like something like it is made like a tree, like right, something a tree. But in the strip plot we do not have like these things. We have simply the dots which are just in a straight line. So this is a strip plot. Fine. So this is basically how we just make a strip plot, and this is basically how a strip plot looks like. Let me add that next parameter to it. So I would just write sns dot cat plot. Okay, sns dot cat plot. I would just write the bracket. Again, I would just write data is equal to t. I would just put a comma. Then kind is equal to strip. Right? Kind is equal to strip. Now what I would just write, I would just give the value for x. X is day, and y is equal to total bill. So that's total underscore bill. And I will add okay, hue is equal to smoker. So you can just like take different more things. Okay, fine. So here I just added the hue is equal to smoker. So I just got that the smoker like yes, the smoker was this much on this particular day and the total bill was this much, and no, and yeah, this things. Okay, fine. This is basically how this like a strip plot looks like. Now what next plot we have? Next plot which I have a box plot. Fine. So the kind for this plot is box. So I will just write sns dot, okay, not act, it is cat. Okay, sns dot cat plot. I would just take data is equal to t, and now I would just write here as kind is equal to, and here I would just write bo. Okay, kind is equal to box. Fine, kind I have just given as box, and I would just keep this inside the, okay, I would just keep this thing inside the semicolons itself. Fine. So yeah, Now let's put a comma. I would just write x is equal to, this is x is equal would be day. I would just write y is equal to will be total underscore bill. BI double L, fine. And I would just like, now I would just give the smoker also this side only, fine. So I would just write a smoker is hue is equal to a smoker. Okay, hue is equal to, and then smoker. I'll just run that thing. Okay. So this is basically how a box plot looks like, and basically what are these lines, what are these dash inside this box plot. So I'm not going to explain this thing right now because I have already made a very detailed video on this box plot inside my statistics playlist. Okay, so you can just go to my statistics playlist and there you can just search about the box plot. There you will just get that what this line means, that what horizontal lines means, what these vertical lines means, basically why this straight line is written in the middle, and all that things you will just get to know very clearly, fine. So I'm not going to tell these things right now. So this is about the box, and I have now my last kind. Okay, I would just write here SNS dot, and that is a point plot. Okay, POINT. So I would just write SNS dot cat plot. Here I would just write again data is equal to t, then I would just write kind is equal to point. Okay, POINT. Now what else I have? I have x is equal to d. Fine, what I have y is equal to total underscore bill. And the next I have hue is equal to smoker. Run. Okay, so here you will just get a point plot. Okay, so this is basically how a point plot looks. It looks interesting, right? So whenever we are just going to study the whole detail about the scat plot, it will take a wonderful time, and it is interesting. It looks basically interesting, right? So smoker yes, so this blue lines, smoker no, these orange, yeah, it looks wonderful. Okay. So these are the basically kinds which we have inside the cat plot, fine. So these are the kinds which we have inside the cat plot, and I have just taken the same column and the same columns for the demonstration of all these kinds. So let me quickly again show you all of these. So first one was the swarm, second one was the violin, third one was the bar, fourth one was the strip, fifth one was the box, and sixth one was the point plot. So these were the 6 kinds which we have inside the cat plot, fine. So here we have completed this cat plot kinds, that basically whatever the kinds are in the cat plot, we have just completed all of that things in today's video. Now what I would do is I would just show you all of the plots which we have made till now. So these were the plots. First one was the scatter plot which we have just seen in the very first video, and then I have just introduced you to some parameter. First was hue, then moving towards the, yeah, I was just taken to hue, and what was the else? Else was size also. Then we were having style, style, size, and all that things. Okay, I just told you about this legend one which we have used from the matplotlib library. What else I was having? And yeah, I was having reg rich plot. After that I just told you the difference between rich plot and that scatter plot. Then basically what I have just one more parameter inside this rich plot, and that was marker. I just told you that thing. After that we move towards the line plot. So these were the line plots which we have made, and inside that also we have seen several parameters, hue and style. And after that we have just moved towards the bar plot, and after that bar plot we have moved towards the cat plot, and inside this cat plots we were having different kinds, and which I just told you all the things right now. Okay, so this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi, and today we are going to discuss about pair plot, recit plot and boxing plot. So basically these 3 are the types of plots which we have basically whenever we just want to do some data analysis, whenever we basically used to do some EDA, okay, perform that EDA. So in that basically these 3 plots are more plots which we are needed, right? So what are the things which we are just doing in this particular series? So in this particular series what I am just taking here is that I have just taken a particular library, that is Seaborn, right? And whatever the plots are there in Seaborn which are used to make the which I'm used to make the graphs, and which I used to study the data. I'm just telling you about all of that plots in a detail, right? So we are just discussing about all of these plots which are used for doing the exploratory data analysis in basically in a data set whenever you just got that. Okay, so let's begin the lecture video for today. And here what I have a library, that is NumPy, right? So the libraries which I have imported is the first one is the numpy. So I have written import numpy as np. So np is the short form which I have given to this particular library, right? What next I have? Next I have import pandas. So pandas is the second library which I have here imported, and the name for this as I have just given as pd, right? Short form as pd. Third I have cbon, right? So I have written import cbon as sns. So in sns basically the short form which I have given to the cbon library. And moving towards the fourth, I have taken the matplotlib.pyplot as plt, right? So these are all of the libraries which we are just taking right here, okay? So we are just going to work over all of these libraries in this particular data set, right? So my data set is tips. Now I have not taken a data set which I have stored in my laptop or basically a device, okay? So this is a data set which is available online. So basically this is a data set which is there in the cbon library itself, okay? So like for that I have written here that t is equal to sns dot load underscore dataset, and in bracket I have written the name for that dataset and it is tips, right? So this is basically the idea, and then I have just tried like doing all the things, head, tail, and many more things. I have just done that, okay? And if you just want to go and have a better idea what we have done previously, so you can just go and have a look over the playlist which we are just like working right now, okay? That is the data analysis on tips data set, right? These are all the things which we have completed. Now today is a turn for the pair plot. Firstly we are going to see that basically how we just make the pair plots, right? So for that just let me quickly write sns dot, okay? Firstly I would just set a particular theme, okay? Set a particular theme, okay? So theme, okay? And in the bracket I would just write here as style is equal to text. Okay, text means basically I just want it in the pair plot. Basically what gives, it gives like lot much of data, okay? Lot much of like things from that data. So basically what we just wanted that all of these things should be displayed in the x and y axis and basically in the proper way. So that is why I just wrote here as style is equal to text. Now when I would just write the whole program and run, then I would basically let you know that what is here text, okay? So for that you just need to wait for a little while. So I would just write your sns dot pair plot, okay? So this is basically how we just write that pair plot, okay? So it is sns dot pair plot. Now what next I have? Next I would just put the bracket, right? And now here I will just write the name from a data frame, and that is df, okay? And what I would give here, I would give here a hue, okay? Let's say hue for me is time. Let's say I just take this one, okay? So time is one of the columns which we are having, right? Let me just quickly go above and let me show you that thing. Fine. So this is time is one of the columns which we are having in our data. So just now I would just go down and let me just run this program, this code whatever I have just written. Okay, so basically it is saying me that df is not defined. So just let me check that what I have taken. Okay, I'm sorry. Here instead of df I have taken t. Okay, so I would just write t here. Let me just again go down and fine. Here just let's quickly write here as t. Fine. Now let's run it once more, and yeah, basically it will run and it is going to give you the proper plot. Basically it will take a little bit of time because as I just told that it is like it is going to give you a lot of data, right? Now see here what you have just got. You have got many plots here, right? Scatter plots and even some histograms and all of that things you are just getting here. Now what are you getting between? See, tip fraction and total bill, tip fraction and tip fraction size, and tip fraction and tip fraction. So these are the x and y axis on which you are just getting this this plot, okay? Now to study this plot, we'll not move into that thing for right now. For studying all of these things, you will just see it later. But why here I have just taken as hue is equal to time, because here this blue and like orange and blue color things are separated, right? So this is because of the hue which I have taken, okay? Now, instead of this time, I can even take one more hue, that is smoker, okay? Smoker, S-M-O-K-E-R, and I will just run that. After running that, here also I would be just getting the required output, and just let's wait for that, because as I told that it is going to take some time, right? So here you just got that. So now here you can just see that blue color is like telling that smoker is yes on that particular date, okay? Date or whatever the column x and y axis values are being here, okay? and orange one is showing that it is no. Fine, so I just hope you just got the idea how to make a pair plot. Okay, pair plot using the seaborn library. Now let's quickly move towards the second plot for today, and that is resid plot. I would just spell it as RESIDPLOT. Okay, right? So just let me show you that how we just do the thing. So I would just write here SNS dot resid plot. Okay, and I will just put a bracket. So my data is equal to t, right? My data is t, and I will just give some x and y columns. So for x, I would be just giving as small t, and I would just give it as total bill, okay? Total underscore bill, fine. I would be just doing the same thing for y. Also for y, I would be giving it as something TIFF fraction. Let's say TIFF fraction, okay? TIFF fraction. Now what I have here, I have one thing that is Lunas. Okay, I would just not show that thing right now. Just like run this program for a while. Okay, let me just quickly run that. Fine. See, this is basically what is called a reset plot. Now here you can just see your like margin, right? So below that you have negative values as well. So this is basically what is called as a reset plot. This is how you just make it. Now in this basically you have some more parameters. Let me just quickly write that. So here we have one parameter that is color, okay? So let's say I just want the red color. So I would just write color is equal to R. And yeah, you can just see that the blue dots have changed into red color because I have written the particular color is equal to R. Now what next I have? Here I would just write lowness, okay? LOWNESS. Now what does this basically means? So I would just not let you know right now because as soon as I'm gonna run the program, you will just get that thing on your own only, fine? Okay, LOWNESS. Okay, basically it is showing that lowness is equal to true. Finally, let's see that what's the thing, and I don't know. Okay, just let me check out that thing. Just let me delete it for a while. Okay, fine. Let me just put that bracket. Now let me just run it once more. Fine. Now it is basically not taking that lowness. Let's not go into that thing for right now. We'll just cover that thing in the last of this video, okay? But like before that, let me just quickly show you how to make the box and plot itself. This is the last plot which we are just gonna make for today, okay? Let me just write here as SNS dot box and plot, okay? SNS dot box and plot. I will just put the bracket. I would just write x is equal to, let's say I just take the x parameter as day, fine. I would just take my y parameter as a fraction. So tip underscore fraction. Now what I have here, I will be taking color. Now let's say I just specify a particular color, that is B, okay? Now I just want the scale to be linear, okay? I'll just write here a scale and linear, okay? And what else I have, and I need to write that what is the name for my data. So my data is equal to t, and I would just run that. Fine, so here you can just see that here we have got the box and plot. So this is basically what box and plot looks like. It is something like box plot, right? It looks something like that. Yeah, so basically this is the whole idea about making this box and plot. That's how you are just gonna do that thing. Fine, so we have just made that thing. On the x we have taken days, and on the y we have taken the tip fraction. Now if you just want to change the color, let's say from blue I just want to take R, that is red, right? So I will just do that thing, and yeah, you can just see that the color has been changed here to red. Fine, so this is basically how you just make this box and plot. Now let's quickly move towards the reset plot for once more, and I would just try to write this thing in the next line here. I would just try to see the syntax basically, okay? SNS dot, and here I would be just writing as reset, RESID, reset plot, and in the bracket I would be writing fine. So here let me just quickly check lowness. Okay, it's lowest. Okay, instead of this that n we have LOWESS. So just let me do the spelling correct here. So here I would just write comma. I would write LOWESS. Okay, is equal to true. And now I would just run this. Now it will basically not show me any error. And yeah, you can just see that. Now here you can just see that you have got one more red line, right? One is the dotted line, which is basically pointing that, okay, this is the margin for zero origin. And another, you have just got a red line. So this is basically what is called as lowest is equal to true. Fine. So I hope you just got the idea that basically how this pair plot, reset plot, and boxed plots are made. And basically how you're just going to make all these things whenever you just got a data, right? So In box and plot, what we have done, I have taken a categorical variable and even a numerical variable, and I have just plot the this box and plot between these two. And in this reset plot, I have taken both the numerical values, and in box and plot, reset plot, we are having a little bit of lowness, so that spelling was right. Wrong. Okay, so the correct spelling is LOWESS, not LOWNESS. Okay, so that is the whole idea, and we have even discussed about the pair plot. So pair plots are the plots which basically help you to give a better view and a proper view about your data itself. Okay, so I hope you just got all the ideas that basically how you are just gonna make all of these three plots if you're just gonna get some data and someone asks you to make these plots, right? So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi and today we are going to see some other plots in basically that Seaborn library, right? So previously what we were doing, just let me quickly give you a recap that what we have done till now in this particular tips data set which we have taken as a sample for explaining you all of the plots which you can make using that Seaborn library, okay? So firstly, what I have done, I have imported the required libraries which I need here for making my plots, right? The first library was the NumPy library, okay? So I have written import NumPy as NP. So basically what is NP? NP is a short form which I have given to that library. Now, next is Pandas. So why I have just imported Pandas? Because Pandas is used for reading the data, right? So my data which I have taken, which was tips. So tips data set is like we need to read that, okay? But the data which we have taken is tips, and tips is one of the data that is already stored in the Seaborn library, okay? So in that case, I haven't used this pandas library. In that case, I have used this Seaborn library for which I have written import Seaborn as SNS, right? So in because I have just taken the data set which is already stored in that Seaborn library, right? So I cannot read that thing using pandas, right? If I'm going to do that, then I'm just going to get some errors, right? Some exceptions, some errors that this Seaborn is the data which is basically stored in Seaborn library. The tips is the data, but why we are just like using it from the pandas, right? So the data which is stored in the particular library, you just need to use that library for reading that particular data, fine. So and even we have just taken the matplotlib.pyplot as plt because this was one of the in one of the plots we have just used this matplotlib.pyplot as plt for some more functioning, right? So that is why I have just taken it here, right? So these are the libraries which we are dealing with in this particular tips data set. So I would just quickly revise that once more, that are NumPy, Pandas, Seaborn and matplotlib.pyplot, right? Next, what I am taking, next I am taking this how to just load my data, right? So for that I have taken a variable. So I hope you have just written all of the codes with me from the previous videos itself, right? And we will be just continuing it for today also, and even if you have not done that thing, so quickly go and watch the previous videos and have a proper look over all of the things and just write that on the Google Colab notebook, because till the time you're not going to practice these things, you're not going to get any of these concepts very clearly. I'm not saying that you will not get the concepts, you will get, but you will not get them clearly, right? So just practice with me right here only, fine. So t is the variable which I have taken, fine. And in that case, what I have just used, I have used my Seaborn library and I had just given it a short form for SNS. So I have just used that. After that I have used load underscore dataset and the name of the data which is tips, fine. So this is the whole idea about using this and how we are just loading the data. And then we just take about the head and tail, that basically what is our data, right? So in the data which we are having columns total bill, tip, and then gender, smoker, day, time, and size. So these are the columns which we are having in our data set, and we had just included one more column, and that column was tip fraction, okay? So now we are just with these all of these columns, right? So I would just not repeat all these things once more. Let's quickly move towards the plots for today which we are going to make, right? So I have just explained you and given you a little bit of idea that what we have done previously, okay? Right. So the plot which we are going to see today is lmplot, okay? I would just put a comment and I will just write the name of that plot itself here. Okay, this lmplot. Now it is a plot which we are going to see today. Okay, this is a plot which is basically in use to like made by using the Seaborn library. Fine. So for that, firstly what I would do, I would just like set that text. Okay, set the style. So SNS dot set underscore theme. This I have already explained in the previous video, that basically how we just do this thing, right? And I would just put the brackets. Now inside that brackets I would just write style is equal to, I would just right, so style is equal to, and here I would just add text. Fine. So this is the thing which I have just done right now. Now I'm just going to write the code for making my lm plot, right? Okay, so firstly I would just use my Seaborn library, as we have just going to make using the Seaborn library. So I have just taken the short form, that is SNS, right? Listen to my words very carefully from now, because now we are just going to deal with the syntax, like parameters and the syntax, whatever are there in lm plot, and I'm going to tell about all of that parameters in one code itself, right? I'm just not going to write these codes in different lines. I will just write one code and I will just define all the parameters here. Okay, so let's listen to my words very carefully now. So SNS dot, I will just write the name of that plot which I am going to build, that is ln plot. Fine. Next, I would just justify my x and y columns. So let's see, on my x, I just want the column that is total bill. Okay, that is numerical column. So I just want that total bill should be displayed on my x axis, right? Moving towards my y axis, on my y axis I just want that tip fraction would be displayed. Okay, I would just write tip, and here I would just write as fraction, right? Now what I have one parameter, that is COL. Okay, that is basically my color, that what color you want. So let's say I just want 4 different colors based upon my days. Okay, so the days which we are having in our plot, in our data, let me just quickly show you that thing. Let me just go above, and where's my data? Yeah, so here somewhat we have some days, like okay, in the Sunday is there, Sunday, Saturday. Yeah, you can just see here Saturday, Thursday, Sunday. So basically in between Friday would also be there. Okay, so this is the whole idea about how you're just gonna do that thing. Just let me go down once more. And yeah, so here you can see that we have already made one plot for the days. So in that basically we are having 4 days, that are Thursday, Friday, Saturday and Sunday in our data set, right? Whatever we are just dealing with. So in that case I would be getting 4 different colors, because in my color column I have put my day, right? So in that case I'm just going to get 4 different colors, right? I would go down, because if I'm just going to write in one line it would be like very mess up, right? So I would just write downside. Now I have the parameter that is hue also. So in that hue case I just want to add day only, right? In the hue also I want to add day, and in my column also I just want to add day. Now what next I need to write my data, that my data, in which variable basically have you stored your data. So in our case basically we have stored the data in that T column, right? For me I have just stored in that particular one, right? Now what I'm just left with, here we have one more one more function, that is COL wrap. Okay, so this column wrap is equal to 2. Fine. This is one more parameter which we have in this lm plot. After that I have CI, that I would just put as none. Okay, after I will just put as none. Now what next I have palette. Now palette basically is for the colors, right? PALE. Okay, I would just write this time down itself. Okay, so I have palette also, in which I just like we need to put some colors, but I would just not put like any particular color here. Fine. Now what next I even have the height. So whatever the height you just want to give to your plot, okay, so in that case you can just give that particular height. In my case, let's say I would just write as 4. Okay, I would just write as 4 the height. Now what next, or what else I have one more parameter, that is scatter underscore KWS, right? So in that basically you need to give some values. Okay, so I would just go down here, I would put that bracket, and inside this I would just write as is like colon then 50, because here I just told that we need to give some values, right? And I need to give some value for alpha itself. Okay, so it's ALPHA, and I would just give some value, and let's say the value is equal to 1. Fine. So this is basically how you are just gonna like make and put the things. And I just need to make it colon also. Fine. So this is basically how you are just gonna make your lm Okay, just let's quickly run at, okay, module C1 has, okay, so it's not N, it's L, M. Okay, so I need to, in place of N, I need to write here as M. Fine, I would just run it for a while. Let's quickly see that. Okay, so we are just getting our plot. Fine. Okay, so what we have just got here, we just got 4 plots, right? The first plot is for the day is equal to Thursday. Just see here that what it is written day is equal to Thursday. Second plot I have got day is equal to Friday. You can see the difference in the colors, right? The day Thursday is having the color as blue and the day Friday is having the color as orange. Fine. Next what I have, next I have day is equal to Saturday. So for Saturday I have the color as green and for Sunday I have the color as red. Day is equal to Sunday, so color is red. So this is basically how we just make the LM plot, right? So we will get 4 plots. Why? Because here in the color one and even in the hue I have just put here as day. Now in place of day, if I just gonna put this, okay, just let me explain a little bit more about this day only. So here in this hue I have put the day, right? So because day are 4 in our data set which we are having at a Thursday, Friday, Saturday and Sunday, right? So in that case I am getting these 4 plots. Now if I just take a particular column in which I have only 2 or 3 distinct variables, right? Let's take the example for the smoker. Okay, if I just write here as a smoker in the hue also and in the color also, I just write here as smoker, then I am going to get only 2 plots. One for smoker is equal to yes, and one for smoker is equal to no. I have to just see that. So one I have for smoker is equal to yes and second for smoker is equal to no. So for yes we have the color that is blue and for no we have the color that is orange, right? So this is basically how you just make this LM plot in this Seaborn library. So this is one of the plots which we have discussed. Now moving towards the second plot quickly, I would just name that second plot and that second plot is named as joint plot. Okay, PLO. Fine, let me just quickly write that, basically how we are just going to do that thing. So I would just take a variable, okay, and here I would just use that short form for my Seaborn library and that is SNS. Here I would write, okay, I need to write joint plot. Fine. Now what I would firstly do, I would just firstly give the name for my data. So my data is equal to T, right? I've just given that. So T is a variable in which I have stored my data, right? Now what next I have, okay, so here I would just like justify my x and y columns, fine. So in my x, let's say I just write here as total underscore bill. I would just take total bill, okay. And in y, I would just, let's say I would just take y is equal to, I would just take as tip fraction, let's say, okay, tip underscore fraction, fine. Okay, so tip underscore, okay, I just need to remove one I from here, there are 10, fine, and I will just put a comma and go down. So the things which are just left, I will just write them downside, fine. Now what here I'm just gonna write, I'm just going to add some more things. So I can just even add the hue parameter also, okay, if I just want I can add the hue. So in this case, let's say my hue is a smoker, fine, my hue is a smoker, and what I have, what kind I just want. Okay, so I would just write here kind is equal to KDE. Okay, so this KDE is also one type of plots only. Basically, we have different kinds, right? Kind is equal to joint and some more things which we have already discussed in the joint plot. So in that case, we have one more kind that is KDE. So I have just written that here. I would just run it for a while and then you can just see that basically how this joint plot looks. Right, so this is our joint plot which we have here. So you can just see that joint plot. Now here what we are just seeing, we are just seeing something like histograms, right? And here what we are just seeing, we are just seeing some circles and all that things. So this is basically what is called as the joint plot, right? This is how we just make the joint plot, and we had made it for total bill and tip fraction. These two are the like x and y values for which we had made this joint plot, right? I hope you just got the idea that how we are just gonna make this thing. So even we have taken the hue as a smoker, right? So in that case, we were having two colors. The first two, we are having two cases in the smoker, yes or no. So in the yes, we are getting the blue color, right? And in no, we are getting the orange color, fine. So this is basically how we just make the joint plot and the LM plot. So these were the two more plots in the Seaborn library, and I just hope that you have made these plots with me itself here in this video only, right? And if you have not done that thing, so what are you just waiting for? Quickly open your laptops and just start making the codes with me, right? So this is all for this video. Till then, thank you and bye bye. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today what we are going to learn about that data science and basically that data analysis things which we are going to like doing right now, that is classes and functions for making complex graphics. Now till this point, whatever the graphs, whatever the plots in Seaborn library we have covered, right? That are the basics, okay? Now we have come to an end for the basics of the all the plots whatever we were having in the Seaborn library. Now it's the correct time to move on to a little bit of complex, right? Now the things which we have made previously, right? Let's say that was pair plot, let's say that was grid plot, that was KDE plots and all that plots which we have made previously. Now it's the time to little bit upgrade that plots, right? Now there are several more features which you can just basically add into that plots and just make it a little bit complex and all that things, right? So from now onwards in this data analysis series, we are just going to see that thing, okay? Now, so for that, basically what I would just like to do here is that I would just firstly like to put a heading. That what is the thing that we're gonna cover today, fine? So I will just put a hash here and the name for my topic is basically classes and functions for making, that is for making complex graphics, okay? So the topic for today, okay, I just need to write the correct spelling, JR, okay, I just need to remove when, N and your APHICS, fine. This is the basically things which you are going to learn, and that is classes and functions for making complex graphics, okay. Now let's get started with the things. So previously what we have seen, previously we have dealt with only and only data for the tips, right? That was a Seaborn data, and we had just like seen the plots and all that things in that particular tips data. Now we are not going to do the same thing, okay. Now we'll just change our data. Now our data would be the penguins. Now this penguins is also a data which is available in the Seaborn library itself, okay. We just need not to download that or store that in our devices. We only need to just quickly write the name that okay, this is the data, and it will automatically be imported. And we all just already know that what's the like procedure for importing the Seaborn data, right? Now let's quickly do the same thing. So firstly what I am going to do here is that I would import my library that I am going to use today, okay? And yeah, you all know that the one is a Seaborn library. So I would just write your import, okay? I would just need to write the correct spelling. So it's import Seaborn as SNS. I just need to, okay, that is, and here I will remove one A, fine. So here I have just written import Seaborn as SNS, okay. So here I have just imported my Seaborn library and even given it a short form name, and that is SNS. Now I would just run it for a while and just I would check that is there any issues or not. So it just cleared. And now I just redirected to the new line. From here, firstly, the first thing basically that comes when you are just going to do any data analysis or when you're just going to make any graphs. So the first step is always that loading your data. Loading your basically the library which you are going to use. So that step we have done. Now, second that comes here is that you need to just import the data whatever you are going to use today. So in our case, that one is the penguins data, right? So I would just give it a name, and let's the name which I have given here, and that is df, okay. Df is the short form and like name, and the variable in which I'm going to store my like penguins data, fine. So df is equal to, now here I would just write SNS. Now that is basically the short form for my Seaborn library, right? I have just written that thing, import Seaborn as SNS. So SNS is the short form for this library. So I just wrote df is equal to SNS dot. Now here I'm going to use load underscore and data set. Fine, so data set that is automatically came here. So SNS dot load data set. So we have already seen previously, and now also I'm just repeating the same thing, that basically whenever we just want to load our data that is already present in the Seaborn library. So what we just write the short form of the library, and that is SNS here. We put a dot and we use the function that is load underscore data set. I would put the brackets here, okay. Inside the brackets I'm just going to write here as penguin. So this is the name of my data which I'm going to load here. I would just run it for a while here. That is basically okay. Now I would just write df. So basically what df does, it will show me the top 5 rows. I just need to check that what is the name for the columns that we are having. Okay, so I would just write df dot, and here I would just write head, and I would just run it here. Okay, so it just showed me my top 5 rows, and okay, so my rows are basically, so the columns which I am having, that is species, island, and basically bill length bill depth flipper length, body mass, okay, and gender. Fine. So these are the columns which I am having in my data set. Now I am going to make some plots here. Okay, now let's see that basically what are the things. So here I would just take a variable, and let's say that variable I have taken here as a. Okay, now in that I'm going to write SNS dot pair grids. Firstly, the plot which I am going to make here is the pair grid. Okay, so A is equal to SNS dot pair grid, and in the bracket, okay, I just need to come back to the position, and in the bracket, firstly I would write the name, that is penguins. Okay, so penguins, right. I would just put a comma here, and here I would just write hue. Now we all know that basically what is hue, right? We have already seen that thing in the previous video, so I'm just not going to repeat that right now. Okay, so hue is equal to, now in the hue I'm just going to give the name as species. Okay, so A is equal to SNS dot pair grid. In bracket I have written penguins. Penguins is the data set which I am using. I put a comma, and here I would just write hue is equal to species. I would put again like comma here, and here I would just write corner is equal to true. Okay, so here I have just made my corner is true, and now I would just run it here for a while, and let's see that basically what happens. Okay, so here I just got something, and see here only I just got only the blank ones, because what I have done, I have only made my I only made the pair grid here. Okay, and here I just made the corner is equal to true. Fine, I would just cross it here. Now I would just write the whole code for the program, and then we will just run it at finally. Okay, now what I'm just going to do here is that I would take the, okay, not here, I would just write the same thing in this one only. I would take the variable in which what I have stored my SNS dot pair grid. Okay, pair grid I have just stored basically I have just stored that in my variable, that is A. Okay, now I am gonna use a dot, and here I would just use map underscore lower. Okay, map underscore lower is the function that I am using, as I just mentioned in the very starting only, that from now onwards we are just gonna make some complex graph. Okay, so that will also have some complex parameters, right? That is the absolutely right thing. So here I'm just using that A is my variable in which I have stored my pair grid, a dot map underscore lower. Fine. Now I would put the brackets. Now here I would just use my library short form, and that is SNS for my Seaborn library. So SNS dot, and here I would just write KDE plot. Okay, so KDE is the plot which we are gonna use here. Okay, so SNS dot KDE plot. I would put a comma here. Then comma hue is equal to, now what hue do I basically want here? So in that here I will just write as none. I don't want any hue particular, because in this pair grid I have already taken my hue as a species, so I just need not to mention it here. Fine. So I would just put again a comma, and here I would just write levels. Now what levels do you want? So just let me write here. Okay, now levels is equal to 5. Now basically level is equal to 5, and at last what I am just left with, I'll live with the color, that basically what color you are want. So as I mentioned that, again I'm just telling that we are going to make some complex graphs. So in that now we are just going to give some color values. Now I'm just not going to write the name, that for which column I do want the color and all that things, right? So here I'm just going to add some value here. Fine. So a dot map underscore lower in bracket SNS dot KDE plot, comma hue is equal to none, comma levels is equal to 5, comma color is equal to 0.2. That is okay. Now let's quickly move towards the next one. So for the next one also I'm just gonna like use the same thing. So here I would just write a dot map underscore lower. Okay, a dot map underscore lower. Now inside the bracket I'm gonna use one new plot, and that one is the scatter. First, in the first line I have used my pair grid to make the grids, whatever we have just seen previously. Okay, in the second line I used my KDE plot. Now okay, so KDE plot I just wanted to make that, so I just use this KDE plot. In the third line I'm going to use my scatter plot. Okay, that is also done. I would put a comma, and here I would just set a marker that in what shape I just want the points that appear. Let's say in my case I would just put as plus. Okay, so if I'm just not going to put any marker, any like particular shape, so in that case it is basically going to come in the circles, right? But I just mentioned plus sign here, so all the dots which we will see, that will be appearing in the plus sign, right? I would just put a down line. Now here I would just use a dot, again I would just use the same parameter which we have used, a dot map underscore lower. Now inside this lower function what I am going to use here is that I would be using my SNS dot histplot. Now this is the another plot which I would be using here. Fine. Okay, I would put a comma and just let me quickly show you that. Okay, I just put the comma here. Now here I would just write element, and element is equal to, now what element I'm just going to give here is that element I'm going to give here as fine. I would again put a comma. Now what line width do I want? Okay, so in that case I'm just going to use as line width, width. So line width I want 0. I don't want any line width. Okay, so in that case I just wrote here as 0. Now what next? Okay, I just need to comma, and what next I am just left with, I am left with KDE. Okay, so in that case I'm just going to write that KDE is equal to true. Okay, I'm just setting it as true. Now I would just do enter here. Now what I am left with, now I would just make a frame. Okay, so in that case I would be using a dot add underscore legend. Add underscore legend is the function which I would be using now. So in the bracket I would be writing frame, frame, frame on is equal to true. Okay, just let me quickly show you that thing also. So frame on, okay, I've just written that thing, and here I would just put it as true. So true. Right. Now what next I am left with, here I would be using a dot legend. Okay, a dot legend. Legend is my another function which I am using. So a dot legend. Now here I would just put again a dot, and here I would use the function, and that is okay, that is set underscore b box underscore to anchor. This is my another function which I am just using here, that is set b box to anchor. Okay, and inside the brackets I'm going to give some values here. Okay, let's say my values are 0.61 and comma 0.6. Now values basically differ, so you can just choose some values on your like whatever you want. Then you can just try some hands-on in this, and then again you can change. So this is the like procedure how we learn, correct? Right. So here I just wrote the whole code. In the first line I have just used my pair grid. In the second line I have used my KDE plot. In the third line I used my scatter plot. In the fourth line I used my hist plot. In the fifth line I used dot like add legend function, and at last I used set bbox to anchor. And now I would just run this program for a while, and let's quickly see that basically what output we are gonna get here. Right now we'll be getting some different outputs in different lines, because here we have like used many functions, right? So in that case, right, just let me go above. Okay, so basically my first one is empty. Why it is empty? I just need to check that thing, why it is empty basically. So hue is equal to species. So instead of this penguins, if I would just write here df, and now if I just run it for a while, let's quickly see that once more. So because I have just stored my penguins data into the df, yeah, right, I have just stored that into my df column. So that is why I was just checking that what happened here. Again it is blank, and just let me see that why it is giving me this thing. So okay, body flipper length, and okay, so the first one was KDE plot, right? So okay, so basically the error, let's quickly see that what's the error. So here it's map lower. Okay, I just missed that lower. So instead, okay, just let me put the line here. Okay, so instead of this layer here, it would be DIAG. Okay, so I need to, if I just need to print that his plot, so in that case I just need to use map underscore DIAG, and now I would just run it for a while. Now let's see that basically what happens. Do we again just get some errors, or basically now we are just gonna get the correct output? Okay. So basically, as I mentioned that there are several plots, so it will just take a little bit of time, and yeah, now it is here basically. Now quickly check that the first one was the KDE plot, second one was the scatter plot. Okay, so the KDE plot, then basically you are able to see this, right? Here is scatter plot is also present. Okay. Now third one was the his plot, so scatter plot and then his plot also, right? And this series basically goes on. Now here I am getting the basically these plots over all the columns whichever I am having, basically the numerical columns. Okay, bill length mm, bill depth mm, flipper length, and body mass g. Let's quickly go above and see these four are the numerical numerical columns which I am having in my data set, right? That was bill underscore length underscore mm, bill underscore depth underscore mm, flipper underscore length underscore mm, and body underscore mass underscore g, right? These are the columns which I am having, the numerical columns in my data set. So numerical columns, I will just again tell you the definition, that numerical columns are the columns which are basically having some numerical values associated with them. Okay, and you can just check out here also, you are just getting the same things, right? So this is basically how you can just make some complex graphics using classes and functions. I mentioned that we have used the functions also here, right? We have used several functions there. Okay, so this is the whole idea how you can just make this plots a little bit more complex, a little bit more finer to look into the data. Okay, whatever the data you are having. So here I have taken the data for the penguins, right? So I hope you just got the idea that how you're just gonna do these things. Okay, how you are just gonna make these plots, how you're just gonna make these graphs and all that things, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today what we are basically going to see is that how we can just make a hist plot in Python. So basically hist plot is type of a plot in which is basically like made using the Seaborn library, okay? So till the series of the data analysis, what we are actually seeing is that we are actually seeing that basically, let's say you have taken a data set, okay? Data set is from the Seaborn library itself. Now, how to just plot different kinds of plots using the Seaborn library. So we are seeing all of these things till now, right? So today also I'm just going to continue that thing, and today I'm going to tell you that basically how to make a hist plot in Python, okay? In this basically using the Seaborn library. So what I would just do here for a while, I would just give the heading that what plot actually I'm going to make today. And I will just put a hash here, and here I would just write that I'm just going to make one plot, and that is basically hist plot. So spelling for that is basically HISTPLOT, hist plot. Okay, this is how it is, it's just basically right. Now, so the first step, whenever we just want to import, whenever we just want to read any data or make any plot, or we just want to do data cleaning, or we just want to do data analysis, right? Anything we just want to do from any data. So the very first step that comes here is that. Now just please listen to me very carefully, because I'm just going to tell you the correct steps also for doing the data analysis on a particular data set, okay? So the first step that comes here is the importing of the libraries, right? So you need to import the libraries, whatever you are going to use today in your data analysis, fine? So firstly I would import Seaborn as SNS. So this is a basically library which I am importing because I am going to make the plots using my Seaborn library, correct? So that is the reason that I am importing my Seaborn library. Now, what is the procedure? So procedure is that we will be using import and then writing the name for the library which you need to import. So in our case, the first library that we need to import is Seaborn, right? And after that, basically what we do, we give a basically short form to this Seaborn library, okay? And that we have taken as SNS. Fine. The first line is very clear, right? Now let's move to the second library which we'll be importing, and that is the matplotlib. So basically, matplotlib library is being used a little bit here, okay? Only one function of that library is used in making the hist plot. So I will be just telling you that library, that function, okay? So import matplotlib as let's say I just give it a short form as MPL. Oh, okay. So I would just do MPL. Now, what third I just need to import? I just need the third library which I would be importing is import matplotlib.pyplot as PLT. So here I would be writing import matplotlib. Yes, my matplotlib.pyplot as PLT, right? So these are the three libraries which I have just used here, okay? And what I would just do here, I would just set the style. Style is equal to text, okay? So in that case, I would be writing SNS dot set underscore theme, okay? And in the bracket, style is equal to, and here I would just set the style as text, okay? So I would just write here as single I and text, and now I would just run this program. Fine. So basically it will just run, and yeah, here I just did not got any error because I have written the spellings and everything as correct. Fine. Now after importing the libraries, whenever you're just going to do the data analysis, so after importing the libraries, what's the second step that you need to follow? So the second step is here that you need to write and import the data in this file, okay? Now you need to read your CSV data, whatever the data you are using. It is like either it is from your desktop you are taking it, or you are taking it from any website. That like basically that doesn't matter. So right, so you just need to import your data, read your data into the CSV format, or whatever the format you are having of your data. Right, so here what I would be taking, I would be taking df. Now df is a variable in which what I would be doing, in which I would be reading my data, in which I would be loading my data, right? So previously also, in previous videos also, I have already told you that if you want to read a data, if you just want to import a data from any particular library, okay, so because there are several libraries that are having their own data. So let's just, if we take the example for Seaborn only. So Seaborn is a library which is having its own data, right? So in that case, what we'll be doing, you need to import that data, use that data from that particular library only. So in that case, you need not to download the data on your desktop or devices, okay? So what we'll be using, we will be simply using the name for the library, the short form for the library from which we will be taking that data, okay? So in our case, that library is Seaborn. So I just wrote the short form here for Seaborn, and that is SNS, okay? Now what's the next thing that I would be doing? I would be writing here dot load underscore dataset. So here what I am doing, I am loading the dataset from the Seaborn library, okay? And what is the name for the dataset? The name for that dataset is diamonds. Okay, so diamonds is the dataset that I am importing, that I am loading from the Seaborn library. And now I would just run it, fine. Now let me just quickly explain that what's the whole meaning for the second line. So just listen to me very carefully now. That here I am loading the dataset that is diamonds. Okay, I am loading the dataset that is diamonds from the Seaborn library and storing that data into the variable, and that variable is actually df, right? So I hope now you just got the idea that what's the meaning, absolute correctly meaning for the second line, right? Now what comes here is that I just need to check out that data in my data, that what are the columns and rows which I am having, right? So I'll be putting df dot head. Now about these functions we had already discussed, so I would just not repeat that here for a while, okay? I will just not repeat that thing. Fine. So I have the columns that are caret, cut, color, clarity, depth, table, price, x, y, z. Okay. So these are basically the columns which I am having in my data, right? So here basically we have three. Okay, we have three: categorical and rest are numerical. Fine. So we'll be using some numerical one only for plotting the Histplot. Okay. So I would be just coming down here, and now my next step is that I can even set a particular size, that the plot which should be plotted, I just want this plot to be plotted in this particular size, okay? So for that what I will be doing, I will be writing f comma ax. F comma ax is equal to plt. Now have a look that at like for plt what we had used. For plt is a short form for the library, that is matplotlib.pyplot. So now that is why only why I have just imported this matplotlib.pyplot, because I wanted to set the size for my figures. I want to set the size for my hist plot, okay? So plt dot, and here it is subplots, fine. And in the bracket I would be giving fig size, figsize. Okay, let me show you that thing here. So okay, so plt dot subplot, and in bracket I would be giving fixed size, and here is equal to, and I would be putting the brackets, and inside this brackets I would be passing the value for the length and the breadth, okay? Length and the breadth, fine. Let's say I'm just passing here 8,6, fine. These are the values which I have just passed. You can just like take any one of your choice, that's no issue here, fine. Now what I will be doing, I will be plotting my hist plot here, okay? So sns dot, okay, let me just, yeah, I would be just writing here only. SNS dot hist plot, okay? So SNS is a short form for my Seaborn library, and hist plot is the plot which we are going to make. So I would just put the bracket here, and now, okay, so I would be doing one thing, I will be zooming out a little bit, because otherwise I will not be able to write here, okay? Okay. Right, so SNS dot histplot. Now what I need to do, give the first one, and that is basically I would be giving the variable in which I have stored my data. So in our case that variable name is def, right? Next thing, I would be giving the value for x, okay? Let's say in my case I would be taking the column that is price, okay? I'm just taking numerical column. You can just take any column of your choice. Next parameter which we'll be passing is hue. So in hue also you can just give any column a name, and let's say I just give the cut. Is that there, right? So cut is one of the categorical column, and price is one of the numerical column, right? So I have just taken both of the categorical and numerical both columns. I would put a comma. Now I would just use one more function here, that is multiple, and multiple is equal to stack. Now what I actually mean here is that I would just explain you multiple is equal to stack when I would just run this program and when the figure would come. So at that point I would explain you that what is actually a stack. So I will just give you a brief idea about a stack, that it is a, like, let's say it is a line, okay, and in that lines basically it is subdivided, okay. In that line is particularly subdivided in two parts or three parts or four parts. That is actually called a stack, okay, right. Now what next I would be having, I would put a comment, come down. Now here what I can just do here is that I can just give a color, palette color, okay, that what color actually you want. So I would be using the function, that is palette, and PALETTE. I would put a equal to sign, and here I would just give some name. Let's say that is light colon M dash R. Now you can just basically search out the what are the different palettes in Seaborn through the Google. Okay, you just go and have a look on Google that what's the palette colors, and you can just like try any one of them, whatever you wish. Fine. So now next what I would be doing here, I would be giving some edge color. Okay. So edge color. Now basically whatever the edges would be made, so for that basically we would be giving some particular color. Let's in my case I would be giving 0.3. Okay. Now I also can give a parameter, that is line width. So what in the histogram, whatever the lines will be appearing, okay, what type of, like, what width do you want in that lines, okay. Let's say I just give 0.4 here, 0.4, right. Now what I would just do, I would just again put one comma here and come down basically, and my last one is log underscore scale. Okay, I would just like show you that thing. So log underscore scale is one of the more parameter, and that I would just set here as true, and I would put a comma, and that is now okay. Fine. This is basically how we just define several parameters inside this. Now after this I am left with two more things that I will be just writing here. So just let me quickly remove this one. Fine. So now here what I would be doing is that I would be coming down, okay, and now here I would be using ax dot x axis, okay. Now I would just like setting a format, okay. So here I would be using ax dot x axis dot set underscore major underscore formatter, okay, a formatter. Fine, and inside this basically I would be using my matplotlib library. For that I have given the short form as MPL, remember. So in that case I would be using MPL dot picker dot, and here I would be using scalar formatter, okay, scalar formatter. Fine, and this is the function that I just used, and I would just come down, and now I would be giving the x6 values, okay. So here I will be using ax dot set underscore x6, okay, that we have declared above, remember. I will be putting the bracket and I will be declaring a list here, and I will be giving some values. Let's say that are 500, then 1000. They will be at the interval of 500, okay, somewhat 500. Then like basically they have the values of themselves, okay, 200, and then let's say 5000, and here that is 10,000. Okay, so fine. So here we just wrote the whole code for displaying the histogram, and now I would just run this for a while, and I would just say that invalid argument. Okay, here I just need to put the underscore. Fine. Now I would just run this again for a while here, and let's see that basically what happens. Fine. So here I just got my histogram as the output. Now this is basically what a histogram actually looks like. Okay, this is actually what a histogram looks like. Now here you are able to see lines. Now we had just set a particular width for the line. So all the lines are in that particular width only. That was 0.4. We had done price, and here count is approximately this thing which we have taken, okay. Now what was price? Price was 500, 1000, 2000, 5000 and 10,000. So these were the values which we have set here, right? For the x-axis, what were the values which we have set? So these were the values which I had just set here for the x-axis, that these values should disappear, so should appear in the x-axis, and my histplot should be made here, right? So this is done. Now when I was just talking about multiple stack, okay, the multiple stack, now here you are able to see that there is one single line, and in one single line that line is divided into sub parts, correct? You are able to see that thing, correct? So that is basically what is called as multiple stack. And now if I just remove this palette one, okay, I would just remove this here from here, And now when okay, just let me put it here, and let me quickly copy it, and now I would just remove, and I would just again run my program here for a while. Okay, now you are able to see that it has come into different colors, right? So that basically depends on you, that do you want to give a particular color or you do not want to give a particular color. So here it is like clearly visible, you can like clearly see the different colors, and clearly like take it from here that what is actually the cut, and in cut blue is ideal, orange is premium, green is very good, and then basically pink or just something red is good, and light purple is fair, right? This is actually how a histogram looks like. Okay, so I just hope I made this thing very clear to you, that how to just put all of these things. Now if I just remove this column, that is edge color, I would just remove this also, and I would just remove it from here, and now I would just run my program here for a while. So let's see that basically now what happens. Now you're able to see the difference, right? Previously in edge color, what was happening here, black colors were appearing, so that it was differentiating each and everything very clearly. Now white lines are coming, that are actually not differentiating the things very clearly, right? So that is the reason that why I was just using that here. So I would just again use edge color pointer. Let's say I just make it to 0.4 here, and now I would just run my program here for a while. Now you'll be able to see that now you're able to see the color, right? That color which is present here, and which is actually dividing this, right? So now I hope that you must have got the idea that basically how to make a hist plot, right? So these are the parameters which you can include in this hist plot, and this is how you can just make a hist plot using the data, right? So I hope I just made this thing very clear to you, and even you had made the hist plot on your own using any data set, right? So this is all for this video. Till then, thank you and take care.